For the last 25 years, the most popular power plant used in automobiles has been the internal combustion port-injected engine. The fuel injection system atomizes fuel and air by spraying fuel under pressure through a port valve, which opens and closes at the top of each combustion chamber. In 1953, Mercedes took their Daimler-Benz 601 fighter technology and, with the help of the Bosch company, showcased the first gasoline direct injection automotive gasoline engine in their 300 SL. This was the fastest production car of its time, with a top-end speed of 161 miles per hour. This 3.0 straight-six mechanically driven direct injection engine was ultimately more suitable to racing than mass production. In 1996, Mitsubishi claimed the GDI initials when it mass-produced an inline four-cylinder and then the first six-cylinder engine, and by 2001 had put over 1 million GDI fuel systems on the road in Japan and Europe. At the turn of the 21st century, one after another, manufacturers began rolling out their own GDI designs. Gasoline direct injection has advanced quickly during the last few years, as have opportunities to perform in real-world conditions with various types of fuel. It's now estimated that by 2016, 60% of all new vehicles will have GDI engines. In addition to greater power, drivers also began noticing performance issues in as few as 10,000 miles. And traditional carbon cleanup services were not solving the problem. BG Products and some 20,000 shops that carry their fuel system maintenance products in the U.S. responded to GDI drivability issues. Since 1971, BG has had a reputation for being the solution to fuel system deposits. Today, one of BG's best-selling fuel products, BG 44K, is favored 3-to-1 by service managers nationwide. BG's line of fuel products clean everywhere gasoline travels in the engine. Unfortunately, only air comes in contact with the GDI's intake ports and valves, and it's not the cleanest air. The air intake includes crankcase vapors, which are being recirculated from the engine using a positive crankcase ventilation valve, or the PCV for short. Those oil vapors can coat intake ports and valves and bake into carbon deposits. To better understand how GDI engines perform and how to best solve carbon buildup, BG purchased one of the first 2010 Ford Taurus SHO sedans, featuring Ford's new EcoBoost engine. This gave the technicians in BG's lab the test data they would need to understand how carbon buildup could occur and how it could be cleaned. Now, BG was able to document scientifically gathered data and test possible solutions. As performance data came in, it exposed the same issues BG reps had seen in shops. Unfortunately, the cleaners used in the air induction system do not remove deposits once they've been baked onto the valves, valve stems, and ports of the GDI air intakes. That would require a continuous cleaning solution during engine operation, or the soaking of a carbon cleaning product on valve surfaces between engine operation. There were other problems appearing in direct injected engines. The high heat environment affects injector performance, causing irregular spray patterns from the injector tips. Cylinder wall damage due to carbon scoring appeared when carbon would break off in chunks. Once the data from their first test vehicle confirmed the data from multiple vehicles in service facilities around the US and Canada, the question was, is this consistent with all makes of GDI engines? The data collection was expanded to include 10 vehicles from 8 various manufacturers, foreign and domestic. Collecting and researching the data is currently underway. Here are a few of the examples of carbon buildup in GDI engines. This is the scoring that occurred in the wall of a combustion chamber in a vehicle with under 10,000 miles. These are examples of buildup on the intake valves of the Taurus SHO at 61,537 miles. Here is a side-by-side comparison of piston tops before and after using BG44K. Research to answer the questions about carbon cleanup associated with GDI engines is ongoing. From what we know from the test data so far, vehicles with one specific maintenance program are achieving consistent GDI performance. Prevention is the best cure. Cleaning clogged valves from recirculated crankcase vapors is going to be difficult, but there is a way to make sure it never even happens. The BG GDI Recommended Maintenance Program keeps both GDI fuel and lubrication systems deposit-free. The program includes BG EPR Part Number 109 that cleans the lubrication system, removing deposits from the rings, crankshaft, and lifters. BG Engine Performance Restoration cleans micro passageways to maintain the critical hydraulic function of components like valve train actuators and turbochargers. BG MOA is used at every oil change. MOA reduces harmful acid in the oil caused by heat and friction. On the fuel side, BG44K and BG Supercharge 2 keep the entire fuel system deposit-free in every tank of gas. Direct injection system deposits can be prevented, and BG's GDI recommended maintenance is the best cure.